Hello everyone. This activity, design, build, or both, is going to be using the language of sets, so intersection, union, complement, and all that sorts of stuff, to both build intuition for those mathematical concepts and to talk about equity. And in particular, we can use this to talk about like student representation in the worksheet, so make sure that you tie it in so that students can see themselves as characters in this worksheet, but also as a way to provide role models for STEM. So you want to be able to talk about achievable models and achievable pathways to careers. And feel free to be adaptive. Not every student is interested in a STEM degree. So at the end, there will also be a space that you can, talk about other sorts of professions and such. So what is this activity actually looking at? Well, you start off with just two sets. Keep it nice and simple. And you're working with a team of engineers that are trying to design a device and build it. And so some of them will be designing, some of them will be building, and some of them might be doing both. So the first part is really to get the students interested in the idea, what machine is your team building? So I don't know. For example, Megatron. Make sure you have fun with it. Tell a story. Really get them engaged in the worksheet. This is really where to get them hooked into it. And then in part B, you start talking about the actual numbers, right? So we've got 15 engineers who design and 20 engineers who build. Now, what is the largest possible size of the team? What's the smallest size? And it's not immediately obvious, but with these sorts of sets, it's really easy to start coming up with some visuals to help understanding. So let's say I've got a circle here, a purple circle for designers, and then I've got say an orange circle for engineers. There's who build it. There's more builders than there are designers. Okay, so if there's no overlap between them, so if there's just 28 and 15, well, that's probably going to be the biggest, and then we get 28 plus 15, so 43. But if we allow them to overlap a bit, like this, now some people in the building are also designing and vice versa, and now there's sort of overlap, and you can sort of keep stretching this, and maybe even they're totally contained in each other. So every engineer who is designing is also then going to build, and then in this case the team is only 28. So that would be the smallest. So make sure you use visuals to sort of reason that through. And then in part C, we suppose, okay, what if there is 40 engineers flat out? So the question is, how many people will build but not design? That's a really specific question. I think the best way to sort of try to go about doing this is to really try to fill out this diagram here. So encourage your students to try to look at this question by filling it out. And ask them, what part of this diagram does that correspond to? People who build but not design? Well, I think that corresponds to sort of this area right here. So we really do kind of want to fill out this thing. And make sure you emphasize that, this whole circle here is supposed to be 28, not just this crescent section. Just like how this whole circle here is 15. And if you reason through it, maybe you can start by saying, okay, what if they're totally separate? Well, you get 43, that's too many. And then what if you bring them, so the overlap is 1? Well, you count, and now there's 42, so there's still too many. And you keep doing this, and you say, okay, so eventually the way it's going to work is that there's 3 here, 12, and 25, and then it adds up to 40. And now this answers the question. So you can, again, use these moving circles and use visuals. On the second sheet, it switches gears a little bit, and now we're talking about these heart tokens, and this director of this program is distributing heart tokens, almost kind of like a salary or money, right? And so we're asked to sort of complete this table. It's okay, we have a total number of tokens for each sort of region of the Venn diagram we just filled out, and we want to figure out how many does each engineer get. Well, we just filled out that diagram. We know that there's 3 people who are designers and builders. Total number of tokens 300. Some division tells us that each engineer should get 100 tokens. And then you complete the rest of the table. And then part E allows you to discuss, oh, do we think that this table is fair? Do you like the director's reasoning? Why or why not? What would you change? And then you can fill out your own proposal in the bottom section there. And you can really sort of get the kids to work on their communication skills and to back up their reasoning as for why they've made a certain decision about the distribution of this resource. Cool. And at the very end, I said there was a way you could fold in other things other than STEM. You can make your own puzzle. So maybe you can do something with artists or musicians or therapists, something of that nature, if the kids are interested in it. Really see what they want to do maybe with the math and go off of that.